okay if I begin this talk? Because I have a lot of material to cover. Or we can just enter in the middle of it. So the title of this talk is InternetOgre, and just in case it's not serious enough, I subtitled it Finding Art in Software Architecture. When I first titled this talk, assuming that I'm getting the next screen, Chris Jones from Oracle just said that all I have to do is just open up Donald Knuth's art of computer programming and just print from that. And I thought to myself, well, what has Donald Knuth done for the world other than write like TAC? And as far as I know, like TAC has nothing to do with porn or spam, so therefore it probably has nothing to do with the internet. So because of that, instead of quoting Donald Knuth, I thought I would just quote myself. So here's a quote. I'm always proud when I can explain a complex architecture in a manner simple enough for a non-programmer to understand. That is the height of understanding and the basis of creativity. The person wrote, it's when one of these, the person who quoted that, quoted me. It said, it's when one of these brilliant students stands up and in 2 minutes summarizes everything they learned in a whole month. That's when I feel proud. Thanks, Harry, for the memory. Well, you're welcome, yes. But maybe I should explain who the hell I am. So, apparently, according to Paul Reinheimer, of course, there's some dots in there. I'm Killed Ruby. And maybe I should show you how I quote-unquote killed Ruby. This is TOB's index of Ruby popularity. About in May of 2007 is when I started blogging Ruby. And then July of 2007, I sort of stopped blogging Ruby and then it started to go back up. And then basically, my MO is basically when school goes out, I start blogging about Ruby. And when it starts up again, I stop. And of course, you can see Ruby goes back up again. And then it's Christmas break, so I figured I should start blogging again. And sure enough, it went down again. So actually, it isn't really my blogging, it's just that I'm timing it for the school year. Around this time, I noticed that Delphi just passed Ruby in popularity. And at the same time, a book came out that said it was like Ruby for PHP developers, Rails for PHP developers, and I thought to myself, well, I guess it's time to make a Delphi for Ruby developers. So, well, I've been doing this stuff for about 8 years now, and I guess you could summarize my quote-unquote vast experience with building internet sites with this little clip here.
If you're going to go find a drink, you risk your Christian, this will fuck on anything that's swamp, because we only don't have to consider for the Christian version. Is that not? Maybe there's a good reason you shouldn't go. Give it straight. Why don't you pull some of that old stuff on me? Come on, let's see this off. Fresh, always to make it great. You know how old shit. No, I know what. Maybe I could have decapitated my brothers with the hats on the plate. Got the knife, found the sleeves. Does that sound good to you? No, not really.
So the thing I learned is that the internet is over. Just when you think you really understand it, it'll cut open your spleen and eat your entrails and everything else. Just basically all hell breaks loose. And so, but luckily, there is a solution.
Your information is a lot more vulgar than people think. Exactly. Okay, ogres are like onions. Exactly. No! Oh, you leave out the Senate, your brass start scrabbling by your hands. No! Layers! Onions have layers. Ogres have layers. Onions have layers. You get it. We both have layers.
those layers are a simple like OSI stack model where you're talking about the data layers on top of inside the segments, inside packets, inside strings, inside bits. Or you're talking about, where the hell is my mouse? Software update check started up. Okay, whether you're talking about this or you're talking about like TCP IP packets and then inside them are headers and responses, headers and bodies for HTTP, and inside that HTTP body is HTML, and inside HTML is a header, is a HTML header and HTML body. Whether you're talking about those or you're talking about OSI models or anything, you notice that the internet has layers. So in the case of internet architecture, the layers I want to talk about aren't these layers, but these ones, which are known as the 4 S's of building an internet site, architecting an internet site: stability, scalability, speed, and security. And I will posit that for large consumer-facing websites, this is the order you have to build them in. You should start with the bottom and build up on top of that. Stability on the bottom, then scalability, then speed, then security. Now, if your site has a different sort of structure, like it's an intranet or something like that, or you're building a site for school registration at your high school or college, then these layers may not be in this order. But for large consumer-facing websites like social networks, I believe that I will posit that this is the order you should do it. So let me start with the first one, which is stability. And when I say stability, I mean making it work. So the basic thing is you don't have a website running if your social network isn't up. Then irrespective of everything else, nothing's going to matter. So how are we going to build it so that it will work? What's the easiest way? Well, usually it's very popular to refer to a book, and like all books in this, I'm just going to rip on it. And this is The Loss of Simplicity by John Infinita. Oftentimes people will say, well, what you have to do to build a site is build a simple site first and then build on top of it or retreat on top of it. And the problem with approaching and using a book like this, where the designer is basically this designer, and you follow the rules rudely, is that you'll end up down the wrong path. And the reason why is because he's confounding simple with simplistic and complex versus complicated. In fact, the examples he uses in the book are oftentimes the worst examples because they're straw men that support his argument. So, like the example he uses, like the iPod throughout. Well, fuck, ex post facto, the iPod took over the world, so of course it's a great example for a simple device. But he didn't make the iPod; he had nothing to do with the iPod, and then afterward we just go and find the things that you're looking for that support your argument. But throughout this book, is that underneath that iPod is a very complicated device, and on the surface it's very simple, and therefore, it's simplicity and things like that. So let me explain what I'm talking about. If you were to build a website, and your website would have to scale to, say, just tags level, which is about like 150 of Facebook. So we're talking about 100 million pages a day, around 2 million uniques per day. Then how would you do that? Well, you start building your site, and it's gonna end up looking far more complicated than it seems, or at least at first glance. So if you were to look at this book and then build it, you would just say, what I have to build is a simple architecture, and then a simplistic architecture, and somehow it's magically going to scale, and then I'll just hide all of the mess underneath this large framework that is going to hide all the complexity, just like an iPhone, right? But the actual truth of the matter is that's probably the wrong model. So the model I like to use is birds migrating. So this is a photo I took off of Point Lobos in California of some pelicans flying across. And they always flew across in groups, or usually in groups. And the thing I noticed about them, every time you see birds migrating, is that it exhibits a very, very complicated pattern if you were to look at it as it flies across the sun. But I will tell you that it's not complicated so much as complex. And the rules are not, it's definitely not simplistic. It's actually just a set of simple rules. possible, but not simpler. And that's basically what I'm talking about. If you're a bird flying across the sky, you want to do as least work as possible to get north or south, or where the hell you're going. And so you're flying around, and then you see some other birds like you, so you fly up to those other birds, right? And then you're flying, and you're like, fuck, you know, if I get in the slipstream with that bird, then I have to do less work. So you just do that, and you just fall right in there, and you're like, wow, this is awesome. And you're flapping around in this striping, and pretty soon you see a V across the sky, because each one is like in the slipstream of the other one. Now, as it's going on, the lead bird is like, fuck this, I'm doing too much fucking work, and he gets tired, so he starts slowing down. And then another bird, the bird right next to it, starts to take the lead. Okay? So the rules that are guiding these birds going across the sky are actually rather simple. But the behavior that you see from the outside is very, very complex. Okay? And that's the difference between, if you were to model this at the architectural level, okay, top-down level, I mean, you're just starting, model the thing, and I'm not going to ignore the independence of birds or anything like that, then you're going to end up with a very, very complicated structure. And actually what's going to happen is it'll only be able to exhibit simplistic behavior. So I like to say that simple rules, simple interactions can create complex behaviors, but complicated structures can only exhibit simplistic behaviors. That's why large architectures have problems. In fact, that's the whole philosophy of trying a PHP-style approach. Oftentimes, Rasmus is fond of saying that PHP has a shared nothing architecture. Well, what is shared nothing? Shared nothing means that basically you try to push all the hard work to a different layer and bind to it instead of trying to solve it within the language. A good counterpoint to this is Rails. So Rails has a structure that's called convention over configuration. Well, a natural consequence of convention over configuration is this concept of basically not inventing here. You're not trying to push it out of the layer, you're trying to contain it inside that layer. That's why you see so many things like, I saw recently a MapReduce algorithm written entirely in Ruby, okay? Except when I looked at it, it doesn't even have a reduce function. It's just a map function, okay? Well, no PHP developer in their right mind would try to do MapReduce in PHP. PHP is not the right system to be solving that. They probably bind to like a Hadoop or something like that. So this, shoot, I hate this stuff. This leads to a popular quote of mine, which is that I often say that Rails is like a rounded rectangle and PHP is like a ball of nails. PHP is obviously very ugly. And Rails is like a Macintosh, like a rounded rectangle. And, but on the other hand, I'd like to also say that, well, yeah, PHP may be a ball of nails, but you throw it at stuff and it sticks to shit. Okay? And that's the fundamental difference. So let me show you a very, very simple architecture. Okay? This is how tag is built. So this is a very simple architecture. When you first see it, it seems very, very, very complicated. But when you actually look at it, basically it's a very, very simple architecture. What's going on here is you can just see at this level, this thing there is the website. And that's about, right now, about 160 machines, right? If you were Facebook, that's like thousands, okay? And that thing is basically binding or gluing together everything in this structure. And then you look at here, and this is basically a database relay, and these are the different forms of database, and these are the data stores. And then there's Memcache on the side. And then you look at here, and these are all the Java services that we run. And by the way, this is about a year and a half old. This is about a year and a half old. There's far more Java services now. We use about 30% to 35% of our code base is written in Java. And we bind them as little services that we call. I mean, if you're Facebook, I believe they use, they have their own protocol that is a binary protocol provided to external services that can be written in any language. This is a similar thing here. We're using something called, I can't remember. It's some binary protocol to bind to the Java services because the XML-PC is too slow. At the time, we were using XML-PC, as you can see here. So when you start taking it apart, each one has a very, very well-defined role, a very simple relationship with the ones around it, yet the behavior exists to power a very, very large social network. So that's where, hello, I say complicated structure yields simplistic behavior, but simple roles can create complex behavior. So now, let's say we built our site. Well, how are we going to scale it? Well, first of all, why do we have to scale it? Or what does scalability mean? Well, in my sort of stack world, scalability means to keep it running. So why? Why is scalability the next factor? Well, let's first look at Web 1.0. In Web 1.0, circa 1999, you might even remember the Super Bowl commercials. Or actually, you probably won't. All you'll remember is that there were a lot of them for a lot of internet companies that ended up failing by 2000. So you forgot so many of them because you crashed course in 2000 and because you're drowned out by the message. And that's because they take it backwards. By this I mean, let's look at successful companies like Coke, Microsoft, Starbucks, and Apple, and ask yourself, in terms of advertising, how much money do they spend now versus when they started up? And I will say, and I don't think anyone will take me on this bet, that they spend more advertising dollars now than they did when they started. And I will also take a bet, I will posit that they spend more money now as a fraction of their entire revenue in advertising and PR and other things like that than they did when they started up. Whereas these startups in Web 1.0 world in 2000 were basically spending all this money to convince you to buy a 20-pound bag of dog food for $5 that they ship to you. And somehow they'll be profitable because they'll make it up in volume or they caught you as the customer. Which is sort of backwards. You sort of have to build the product first and then build on top of it. Advertising is something that you use, that they use, like Coke, Microsoft, Apple, and Starbucks use to maintain their brand dominance. In other words, if Coke stopped advertising, then probably in 10 years we'd all be drinking Pepsi. So therefore Coke has no choice but to do advertising and PR more traditional means to maintain their position, not to grow, but to maintain their position, to maintain their mind share inside their markets. Okay? Well, the approach is that in Web 2.0, we have a different approach. And oftentimes, that approach refers to another book called Tipping Point. So this will be the only book that I won't totally rip on, because I actually sort of like it. So the only problem with this book, by the way, is that it's written by Malcolm Gladwell, who's a writer for the New Yorker. And I don't know if any of you guys have a subscription to the New Yorker, but articles in the New Yorker sort of never take a side. They're very, very interesting and they wander back and forth, but they never really take a position. I mean, the New Yorker could be doing a profile on Hitler. They say, you know, but at least he doesn't eat babies or something like that. That's the sort of approach of the New Yorker article, and that's the approach of Malcolm Gladwell in the Tipping Point. He never really tells you anything that is taking a side. He's just talking about various things involving how fads start and how other things become popular. But oftentimes in this book, and I've seen this in interviews with other startup people, where they refer to this tipping point or this hockey stick, is the term that's very popular to be used in this Web 2.0 growth curve, as something like going non-linear. And I will say that that's not true. Let's make tipping point mathematical. So I'm going to ask you to remember your differential equations from college. And you're like, fuck that, you know? Maybe it reminds you of this XKCD cartoon, where he goes, how do you like my centrifuge, Mr. Bond? When I threw the lever, you will feel centrifugal force crush every bone in your body. And it's like, you need centrifugal force. There's no such thing as centrifugal force. A laughable claim, Mr. Bond, perpetuated by overzealous teachers of science. Simply construct Newton's law in a rotating system and you will see centrifugal force term appear as plain as day. Come on now, do you really expect me to do coordinate substitution in my head while strapped to a centrifuge? No, Mr. Bond, I expect you to die. So your question may be, come on, do you expect me to remember first order differential equations that I learned in third year or whatever? And no, I just expect you to die. Or just accept it. But maybe you have a vague recollection. And the vague recollection is this, is that whenever you have like dx dt is equal to kt, but not really. So anytime you have a positive feedback where the new user brings in other users, or a user is bringing in other users, then you have what's called viral growth. So first let me explain viral growth or viral marketing as opposed to other things. Because there's a lot of terminology problem where people talk about just being viral, and that is being whatever. So I will tell you that viral marketing is actually a well-defined term. It means the act of users using your website or your product brings in other users. The very act of doing that. So the act of, the quintessential example, the first example in the internet is Hotmail. The act of you using the Hotmail product acts as an advertiser, a vector for you bringing other users into Hotmail because of that link at the bottom. That's viral growth. And the nice thing about viral growth on the web is it can be very well measured. That's opposed to other forms of marketing like word of mouth marketing. In word of mouth marketing, the act of you using the product, like let's say my Bose headphones that I have on for the flight up, doesn't actually bring in other people to use the product unless they ask me about it. Okay? I'm not actually bringing in by using the product per se. So that's viral growth. So that equation is EXPT is equal to KT because the act of me using it acts as a slope to bring in other users into the system. And the solutions to that are e to the KT. It's a linear differential equation. It's not about going nonlinear. Where does nonlinearity occur? Well, if you were to work out this differential equation and you look over time step t, then what you find out is one user down this viral pipeline. And what a viral pipeline means is that at any given point, you can lose a user. User visits your site, only a certain fraction of the users will go click on the home page or click on the register link. And only a certain fraction of those users will complete the registration page. And only a certain fraction of those users will import their address book. And only a certain fraction of those users who receive that, who receive the sent email, will bother even getting that email past their spam filters, or clicking on that email to see what it said, or clicking on the link inside the email to visit the site again. When you do that entire loop, if a user over a period of time t, which is a time of decay that you're measuring, brings in less than one other user, then the solutions to the continuous equation, e to the kt, is k less than 0 and you have viral decay. You're going to have to support your growth with some other thing, like a traditional advertising. But if a user brings in greater than one other user, by the way, I mean 1.0001 other users, then you have k greater than 0 and you have viral growth. So what does that mean? That means it sort of explains everything you've ever heard about the hockey stick. You know, you go in and you're like, shit, you turn some knob somewhere, you change something, and you're like, oh, we're still getting 10 users a day. And then the next thing you come in, you're like, wow, we got 15 users today. Then the next time you're like, holy shit, we got 100 users today. And the next day you go in and you're like, wow, we got like 600 users. And the next day you come in and your VP is all unheading because your site is down. Okay, that's viral growth because it doesn't matter how small it is, as long as it's greater than 1, then that will just grow exponentially. And you have a Malthusian scenario. So here's basically a story that I like to tell where the smiley makes a difference to show you how big the difference is. Okay? So let's say in your viral curve, and you measure this stuff. So you're measuring the viral pipeline in the drop-off. You have some email subject line that you do to bring in other users, right? Okay, and you want to look at how many people read that email. Okay, well, what you should do is test it. So you send out those emails, and then you send out another version of the email for a certain type of website. You will find out that if you take that same subject line and you add a smiley face to the end of it, you will get 20% more users continuing on to the next step of the viral curve than not. Now, this isn't for all cases, by the way. Okay? So I don't want you just going and say, wow, shit, Terry taught me something. I'm going to put a smiley face at the end of my viral emails. Okay? Unless you measure it, you don't know. So I'll give you an example. In Tag's case, it is 20%. But in LinkedIn's case, it isn't. That's why you don't get smiley faces at the end of LinkedIn emails. Okay? So it really depends on what it is. And LinkedIn measured it, and Tag measured it, and Plaxis measured it. All these companies do these sort of measurements and know exactly where they are on that K-curve. They know exactly if the user's bringing less than 1 user or greater than 1 user. So you can literally turn on growth at a notch. So we jumped from like something like 10 million users to 60 million users in like 3 months. Okay? Or 50 million in like 3 months. It's that easy. if you know what you're doing. Okay? You just have to do it right. So think of that plus 20%. It may be that plus 20% is the difference between failure and success. You may be at 0.999 when you do the multiplication. Now you're at 1.1, and now you have uncontrolled growth. That's what I'm trying to point out. Unless you measure this stuff, you really don't know what's going to happen. But nonetheless, that's the general point, is that viral growth is the way Web 2.0 companies like social networks and other things that have social networking components go and get around the problem of trying to do marketing without having money to do it. Traditional marketing is more geared to brand maintenance than bringing new users. So to establish yourself, you basically depend on your user base to bring in other users. Okay? And then when you do that, you basically live and die by that sword. That sword is exponential growth. Okay? And that exponential growth curve is what I mean when I'm talking about scalability. Because this is why Ruby on Rails, I should say, fails. And that is basically the concept of active record. So an active record is the fundamental pattern under which the Rails framework, which is written in Ruby, is built on. And the problem with an active record thing is that you have an equation between, there are two problems. The first problem is you have an equation between a row on the database and an object store. Okay? And the problem with that equation is this, okay, is that row on the database will have to be split if you're going to do viral growth into two rows. Okay? So if I friend you and you friend me and we're going to have to do federation where we have multiple databases, and we're going to have to split that data. Okay? In other words, we're going to have to store it. Data's no longer normalized. We're going to store it in two places on two separate databases in order to scale this stuff so that we don't die when the hockey stick comes. Okay? And active record doesn't work that way. So what you're going to have to do, if you build your site, a Web 2.0 viral growth type website in Rails, is you're going to have to go in, unless you know what your growth is capped, no one's using your site, like your 37 signals, like you have no traffic, then unless you're doing that, you're going to have to go in and you're going to have to go in and if you're building it on Rails or a framework built on this sort of active record or persistent patterns, you're going to have to go in and rip out the very things that attracted you to Rails in the first place. You're going to have to rip out this part and refactor it so it doesn't do that. It doesn't have this equation inside. And the other problem with Rails is that you're extracted from the wrong part. We know traditionally that databases are very, very big bottlenecks on the web. Databases have always been the bottlenecks. In fact, PHP's growth is entirely tied to the fact that up until recently, App Server was never the bottleneck. Okay? We were always waiting on the database, so it never mattered that the PHP engine was slow as dog. Okay? But the problem is you know that you're going to have the database as your bottleneck. And you're abstracting yourself from the very thing that you know right now to optimize. It's very rare in the world that we find a problem where we already know where we're going to have to optimize. Okay? Usually you have to do testing. You have to do metrics to figure out what component needs to be optimized. You don't know prima facie. But on the web, you know the database is always going to be a bottleneck. No matter how big your memcache is, you're going to have that. So the Pareto principle is basically the 90-10 rule. And Rails is for large consumer-facing websites, not one-offs, not like small sites, but even for certain enterprise sites, Rails is basically writing 90% of your code that's only going to take 10% of your time down the road. And actually you see that. You see a lot of Rails sites that they build it and they grow to a certain size, and instead of continuing and nurturing that product, they build another Rails product, and then another one. Okay, 37 signals is a wonderful example of that, of trying to exploit the Pareto principle backwards by building multiple products, each of which have no users, right? And you can go and you look at Write-In Only and all of those sites, and you see the same thing. But when a site really takes off, like a Twitter, and then everything's in it, then you see all these problems because that site is built to stay, and Rails wrote the wrong part of that code. Okay? In fact, it encouraged those developers, by its very nature, to take a problem that everyone knows is a one-to-many relationship that shouldn't be done in something like Rails and try to do it in something like Rails, okay, or a framework like that. I mean, if you were to do that side of PHP, the really difficult problems of scaling Twitter a layer that's going to handle the message queue system, right? And so you would think, oh, I don't need to build that. I shouldn't build that message queue system PHP because PHP is going to perform like shit on that. And you wouldn't have entered into the promise clearer hat because you wouldn't have been given the tool to shoot yourself in the foot. So on to the next one, which is speed. So when I say speed, I mean making it fast. So the big one I want to talk about is Memcache. Because I think, but first I want to say that Andre likes to say that ABC is the best thing to happen to PHP since Raspberry stopped working on it, single-handedly. But I like to cut it right there. And ABC is so important for building sites now that it's going to be bundled in PHP 6. Okay? That's a code catcher system. Well, if ABC is the most important thing to happen in the PHP world, then I would posit that Memcache is the best thing we've ever stolen from the code world. Because Memcache allows us to basically turn the website into a computer where Memcache is like the level 1 or level 2 cache, and we don't have to go over RAM, and we don't have to go to disk all the time, i.e. the database. And that is a very, very, very big thing. That's how we get a lot of speed, is by using database and Memcache correctly. So in the architecture I showed you, you can see that the website is heavily dependent on Memcache. In fact, even the Java layers have their own Memcache that they're dependent on. And then we go to that before we go to the database. Okay? And so I want to talk about the rock and the hard place. If I was talking about Ruby, I'd say that Ruby's danger, when I say Ruby, I mean Ruby on the web. Ruby on the web's danger is that they're caught between the Pareto principle on one hand, meaning building sites that are going to have to live long, and therefore it would be better to build your own framework as needed, okay, versus downloading WordPress on the other hand. That's the rock and the hard place, which is that Ruby makes it very easy to build a WordPress. You can build it in like probably in a week. You can build a WordPress. The problem is you can download WordPress from WordPress.com and install it, hell, with a click of a button if you're using Dreamhost, literally. Okay? So you're talking, and WordPress is like super popular because it's so damn easy to install. Even if you were to do it from scratch, install from scratch probably takes about 5 minutes. Unzip, and then you visit a page and you type in your database, and now you're good to go. Well, that I would say is biggest sort of danger to the PHP world is the rock and hard place of PHP is between Memcache and Ajax. Ajax has pushed a lot of the templating code, a lot of that stuff onto the website, in terms of HTML and things like that. A lot of processing is there. And then Memcache has gone on the ground and actually caused it so that your app server is now a performance bottleneck. Okay? Because Memcache returns so fast relative to disk or database. That really, when we're talking about it, PHP is now a bottleneck. And you see that in sites like Facebook and things like that, where you're running into issues. And that's why things like ABC are going to be bundled with PHP. So also when I say fast, I mean fast to develop. No matter where I've been, I've seen that people can only write about 1,000 lines per day. That includes me. Unless you're a JTE developer, then you can write about 3. But they're really good lines. They're really good lines. So when I talk about scripting languages like PHP, it's simply about how big is your lever. One assembly line is equal to 1 line of assembly. 1 line of C is about 3-ish lines of assembly. 1 line of BASIC does about 7-ish lines, and 1 line of PHP is about 15-ish. So one PHP developer, look, at a company I work for, they were built on C. Okay? And I'm a PHP developer by trade, so I was doing some templating and other things. And I was talking to the C developers, and we had a developer there, an architect, who was really awesome C++ code. And I was trying to explain to him, yeah, sure, you're awesome and everything, but you don't understand. You're like that dude with 2 hammers, and I'm the guy with the jackhammer. Or you're like the Paul Bunyan, and I'm the dude with the chainsaw. And the fact is that he was amazing, right? Far better than me at C. In fact, probably even at C, he's better than me at PHP. But it doesn't matter, because I don't work very hard, right? That's why I'm an architect. And so that other people do the work for me. And people building their stuff on scripting languages, they don't have to work very hard to get a huge amount of output. So eventually you just get your ass kicked in by by people who are writing about 1,000 lines a day that leverage about 15,000 lines a piece of code. No, skip this one. It's already done. So, just in terms of the scalability and stuff, just some quotes, which is that languages don't scale, architectures do, which Cal is on the same. And just where we come. See, what is happening, why we bring Memcache back into the fold, is that social networking, Friendster had issues. And the reason why is because nobody knew what the social network problem looked like when Friendster was growing. So they didn't know about Memcache and bits solutions like that. And it turned out, like Hubris, they thought it was just a CMS problem, and that PHP would kick its ass. So when those Java engines were failing, they weren't interested in the problems that Java developers had. They were going to do it all in PHP, and that's why it was down for like 2 years. Okay? And that's the thing, is that different problems have different dynamics. The dynamics of Twitter is different than the dynamics of CAD. And the dynamics of CAD and Facebook is way different than the dynamics of CMS. Okay? And that's why you needed Memcache and things like that. So, some things about security, which is my last one. So actually, security is sort of general. And a lot of people disagree about me saying put security last for consumer-facing website. But what I mean is, in security, I mean it's a catch-all, which is make it rich, make money off of it. Okay? Your approach to the web component world is to get uncontrolled growth and then figure out what to do with it. You know, now that we have all the users, how can we profit off of it? Look at Facebook, look at YouTube, look at CAD. I mean, all of them, CAD is profitable now. I bet you Facebook is probably profitable now. LinkedIn is profitable. Lots of these companies are profitable. They weren't profitable when they started, okay? But they had a huge growth, and now they're just figuring out how to make money off of it. And it's not that easy, because it's not as easy as search where people are looking to buy stuff. So, when you're trying to make money, a lot of people will quote Freakonomics, which is a book I hate. And the reason why is because oftentimes people quote it, and they don't realize that he's guilty of the very things he's espousing against. A very common study that's quoted in this book is the abortion study, which is that legalizing abortion in the 70s, if you go country by country, and you look at it, legalizing abortion in the 70s, or whatever years those occurred in those countries, 20 years later, crime goes way down. Okay? So then it's like, all these liberals say, oh, therefore we should legalize abortion, right? But the problem is, that isn't the natural conclusion of that study. The natural conclusion of that study is what Bill Bennett says, is that we should abort every black baby, or something like that. That's the natural conclusion. Just because it has your political, satisfies your political needs, doesn't mean you should accept it. You should examine it for its truth factor. And the flaw in this study, I'll just tell you straight out, there are two flaws in this study. First of all, he's looking in absolute numbers, absolute crime numbers, not per capita numbers. And the reason he's doing that is because every first world country has negative population growth, and crime goes down. Lo and behold, what he's saying is, if you want to reduce crime, just kill everybody. Well, no wonder you get that result. And then the second problem is that everyone knows that when you're doing econometrics or social statistics, you don't go and go country by country, because that leaves yourself open to systematic error. What you do is you look in subpopulations. In other words, all of these countries have a certain system. They all got wealthier, so of course crime goes down, right? That's the actual correlation. But to protect yourself from that, what you should do is take one country and look into every subpopulation, and you should see the same trend. So if I'm talking about pollution versus death rates, then if I'm measuring pollution rates in a certain area and I'm looking at infant mortality rates, then they should have the trend, whether or not I'm looking in Gary, Indiana, or Pittsburgh, Pennsylvania, one of which has CO and the sea collapse in the 70s and the other one not until the late 80s. Okay, I should see the same trends or effects. So the same is with crime. If you were to take inner city blacks and white suburbians, you would find out that abortion rates are much higher among white suburbs than inner city blacks, where they have less education, less access to facilities, and a strong religious background than you would in white suburbia, where they have all those. And yet you would see that 20 years later, crime isn't changing all in suburbs, which is why Well, I don't have a problem with registered globals. It's not a big deal. But I do have a problem with magic quotes. And I often like to ask the developers when I'm interviewing them, if they're PHP developers, what is the problem with magic quotes? And they can't really answer that. They just say it's bad or it's not security. But let's look at it in a clear, clean security model. This is how you use security. You have a clean model, very simple rule, and it applies again and again and again. And the simple rule when building a site to do security is filter input and escape output. And that's the problem with magic quotes. Magic quotes filters escapes input, right? Because you're quoting the input. And why is that a problem? Well, the problem with that is you're making an implicit assumption of where that data is going to go on input. Okay? So you're assuming it's not going back to the user because you know if it's going back to the user, you have to unescape it and then you have to do HTML entities, which is a different escaping function entirely. Okay? And in fact, nowadays, you find that there are very subtle security holes like MySQL real escape string, and you should be using that instead of escape when you're escaping to a database. See, you run into those sort of things, and you find out that escaping is something that you have to reserve. You have to reserve until you're outputting. Whether that output is a database or back to the user, those are to the app server, those are considered outputs. And whether the inputs are coming in from the database or from a user or from JSON or whatever, those are considered inputs. And the reason why magic quotes existed was because PHP was written in a nicer time when Rasmus just wanted to put up this fucking homepage, and he was the only architect. But now when you architect this website, there's no guarantee when you're building it that you're the one who's going to be maintaining it. So just because you know that the data is escaped properly when it's inputted, doesn't mean that the next guy around is going to do that. That's why you split the two, is so that even if down the road someone else works with it, you're still protected. So you do as much filtering as you can up front and escaping as you can later. Okay? So, what do you think are the largest failings of PHP security? So Ed Bigler, who's a security expert at Purdue, says, I agree with some of the things that Terry J has said about this. The things that tend to make PHP insecure also tend to make it easy to work with. That's like magic quotes. I mean, not magic quotes, but registered globals and things like that. So, in fact, even in some cases, it can be a hindrance to do too much security up front. The best example I can come up with is MySpace. Okay? Nobody in their right mind would have implemented MySpace's security principle. It's so open for cross-site scripting, cross-site request routing to allow people to inject arbitrary HTML on their page. Yet that's why it grew, because people could customize the page. In other words, the security hole was the reason it grew, and MySpace left themselves open to it, but good developers would have never done that or thought that. And today, a site like Tag, which is different from a site like Facebook, which is Tag is more like a MySpace, we have to leave ourselves open for that. So the way we do that is if you were to allow HTML on commenting on your blog, you implement a protocol that's called a whitelist. So what you do is you strip all tags except those that are in a well-defined whitelist. So your process, if you're doing it correctly, is first to normalize all the data. So in other words, you take it, you run it through Tidy, now you have a normal tree. And then you navigate that tree, stripping out everything except what's in that whitelist. But if you were to do that, you wouldn't get MySpace. Because MySpace needs to allow everything in it and they have to delete it. So what you should do is implement a blacklist, where you just go in and you pull out the bad tags. But then you run into a problem. And the problem you run into a tag is this, okay? Is that you're not going to catch every blacklist. Some guy's going to figure out a hole. In fact, just the other day, someone figured out a new hole that involved an iframe tray, where they're bypassing some code, and they're using an iframe they're sending an iframe and also implementing a flash widget to talk to that iframe so that they can go and redirect the user on the top level page, okay? And the fact is, I haven't been anticipated. At one time, I was working on, when I was building this, I was looking at it and it's like, well, there's this bug, I know you can inject JavaScript in CSS. And I said, fuck it, I don't have time to look it up, and I built it without it. But what I did build is I built versioning inside my code. So every time we store that HTML, we store it with the version number of basically my code that processed that HTML. So when it uploads it from Memcache or uploads it from database, that version number is there. So one day someone figured out an exploit that involved a script injection inside the CSS. in the style files, okay? And we had about 2-3 million profiles corrupted within hours, okay? So I said, just give me the exploit. I looked at it and I said, oh shit, yeah, that's that CSS hole. And now I had a nice little exploit. So then I go and I write some tool that basically strips out the JavaScript from the style rules. So I run CSS tidy and then I strip out the style rules on that. I normalize the strip just like I would for tags, and I take it out. And the nice thing is then I put it back into code, we launch new code, and then we still have millions of corrupted profiles. Try to find that across like 8 machines, 8 Oracle servers, which is a lot of fucking stuff. It would take weeks, okay? But what we do instead is this. As the user browses the site, right, it pulls it from Memcache or it pulls it from the database. It comes in from Memcache from the database. If it comes in from Memcache, the version number is out of date. So then it goes and rewrites the process and it sticks it back in Memcache and updates the database. So the user browsing the site ends up clearing it, and I was able to go that night to get drunk at some party. Literally, it was the software party. All those people from Boston. So that's basically the end of my talk. And I should just say that at TAG, we're working on the last point. I'm trying to make it note. And oops. Sorry. What does everyone like? Ogres are not like kings. You know what everybody likes coffee? Have you ever been the first you say, drinking coffee is the game I like coffee? Coffee! No! You can't see it! It's a piece of garbage! Ogres are like onions! End of story! Bye-bye! Coffee may be the most delicious thing on the whole damn planet. You know, I think that's better than money. You have to tissue yourself. This word coffee. So if you didn't get this talk, I'm done now. Is that, as DHA says, I only have 2 words for you. Lobbyist. Our democracy, here's a quote from Al Gore, our democracy is in danger of being hollowed out. In order to reclaim our birthright, we Americans must resolve to repair the system of decay of public forum. We need to create new ways to engage in a genuine, non-manipulative conversation about our future. Americans in both parties should insist on the re-establishment and respect of the rule of reason. That means I hope that there's an opportunity to do some of the things I talked about at your company. But if you disagree, feel free to express that. But act like every Ruby developer out there is technically trying to prove me wrong, and I like that. I mean, that's how we move things forward, is by proving each other wrong. I learn the most when I'm wrong. Okay? But if you still disagree, all I have to say is, I'm really sorry I offended you, but maybe I'm sorry with a smiley face.